Okay, please confirm once my screen is visible. I'm sharing my screen. Are we good to proceed? Okay, thank you for the confirmation. So we are doing what? We are working on Java arrays. So we have solved so many problems in our previous classes. So in the extraday's class, we have learned how to remove duplicates. Okay, if you have an array and if you want to remove duplicates, and we can remove that by using a kind of logic which has been discussed in the extraday's class. So we know how to remove duplicates, and we also know what we know how to sort an array. We also understood how to sort an array, and we also understood how to find the maximum number, first maximum number, second maximum number. And if you get questions like this, we got to know the approach how to find these values, how to answer to these questions, and we know how to swap two numbers. Right, we have discussed so many problems. Okay, there is a problem within a problem, and we have solved those problems as well. Okay, today and we are going to understand how to do the searching in Java array. Okay, if you have an element and if you want to search for a particular element, for example, okay, so today what we are going to learn today, let me specify that first. Searching techniques in Java array. Okay, very simple. If you have an array of elements like 1, 2, 3, 44, 55, 5, 66, 77, 99, 0, minus 1. Okay, so if this is an array, and if you want to find if the target minus 7 is present or not. Okay, so if minus 7 is present inside the array, you should return the index of the array, on which index this minus 7, the target value, is present. If the minus 7 is not present, you need to return what? You need to return minus 1. For example, if let us say that if the target element is 5, okay, if the 5 is found, you need to return the index of the 5. 5 is there in the array. If you assume this as an array, okay, 5 is present already, right, inside this array. And if the 5 is found, you need to return the index number. Target is 5. If it is found in the array, you need to return the index number. What could be the index number of this value 5? Okay, 0, 1, 2, 3, 4. 4 is index number. So we are talking about what? Searching. If you have any value, any target value, and you need to write a program in such a way that if the target is found in the array, you should return the index number. If not, you should return the minus 1. Okay, this is the rule. Please be informed that if the target element is present in the array, you must return index number. You must return its index number. Else, if not, or else, you should return minus 1. Minus 1 signifies that the target value is not there inside the given array. How can we write a program for this? Okay, before even going with an approach, I want to tell you that there are two ways that you can do the searching in Java arrays. One is called as the linear search. Okay. Second one is called as what? The binary search. Okay, this binary search is very, very, very important searching technique. You must definitely understand how to do the binary search. Most of the Java developers, they don't concentrate on this problematic problems on top of arrays. I have included this in the syllabus because are the frequently asked interview questions. Okay, you should be able to develop an intuition in such a way that you should know what are the approaches that you can use to solve a problem, to solve a particular problem. Okay, when you are talking about the searching techniques, ideally there are two searching techniques. One is linear search technique and the second one is binary search technique. I will give you the complete picture about linear search as well as the binary search. First, let us understand what is a linear search. Linear search. Okay, For example, okay, if I have, let me go to the plain screen, focus here. Okay, let me take the values like, I'm taking some random values, 22, 55, 77, 1, 2, 8, 99, 96, 100. Okay, I have some random values. Okay, just imagine that these values are inside an array. Just imagine that all these values are inside an array. Okay, this is how the array looks like. Yes or no? Okay, when you say an array is what? The collection of values. Collection of values. Okay, and you need to have an identifier. Okay, this array is identified with the variable name a. Okay, typically when you write integer a, when integer array a equal to, okay, when you include all the values that I have specified here, okay, behind the scenes, this is what that is happening behind the scenes. Array will be created and it will be represented by the variable name a, right? And we know each and every value is going to be addressed with an index number. Yes or no? Okay, the first value will be addressed or will be identified by the index number. Yes or no? This is going to be identified by index number 0. Okay, so you should not forget these things about the index things especially. Okay, so this is going to be 3, this is 4, okay, and this is going to be 5, this is going to be 6, this is going to be 7, this is going to be 8. Okay, always remember, try to place the index number or try to imagine the index number. Index number should always start with 0. Okay, so what is the linear? The question is, what is the linear search? What is the linear search? Okay, if I have an array like this, if I am asked to find, if if 99 is present or not. So 99 is a value that is what representing a target number, target value. I want to find if 99 is present in this array or not. How can I approach? I can run a for loop. Right? So this for loop will be starting from the index 0. This for loop will start from the index 0. Okay, it gets iterated. It will check each and every index. First it will start from 0, a of 0. The value inside a of 0 is 22, not matching. A of 1, 55, not matching. A of 2, 77, not matching. A of 3, 1, not matching. A of 4, 2, not matching. A of 5, 8, not matching. A of 6, matching. 19 is a target, matching. If it is matching, I should return the index number to the end user. I should return what? I should return the index number to the end user. So 6 is going to be displayed in the console. First scenario. For example, let us assume that my target is not 99. Let us assume that my target value is something like 3. Okay, anyone with eyes can say that this 3 is not available in this array, but so we are writing a program, so we need to write a logic in such a way that this program is trying to identify if 3 is present or not. Okay, so again it will start from what? The 0th index. It has to start from the first 0th index. Okay, so it is 22, 1, the value is 77. The value is 1, the value is 4, the value is 8, the value is 99, the value is 96, the value is 100. And it crosses the boundary. Once it crosses the boundary, the for loop will be destroyed. Okay? When the for loop is getting destroyed, what does it really mean? The target is not found. Yes or no? The targeted number is not found, is not there inside this array. Yes or no? So if that is the case, I should return something to the end user. What is that something? I should return -1. You're able to get this note. If the value is present, return the index number. If value is not present, return the -1. Okay, why the question linear search? Why we have the question why the searching technique is called as a linear search? It starts from, okay, it linearly checks each and every index. from starting to ending. Okay, it is going to check each and every index to check whether the given target value is present or not. It is not going to check like it will check 0 like randomly. It will not jump here directly to the 7th index, then the 3rd index. It's not like that. Linear search means in the sequential order. That's why the name has been given as what? The linear search. Have you understood the practical part? Say yes or no. Have you understood the the things? Are you getting these things in your imagination? Why we call it as linear search? Because of this reason we are calling it as what? Linear search. How to do the coding part, that I will teach you. Okay, same thing. Okay, same thing. If I have to do this, perform this by using the Java code, what I am going to do, I will take an array integer a. Okay, so since it is an array, I should use the square braces. I am going to take some values. So this is integer array, right? Shall we take same values or different values? 22, 55, 77, 1, 2, 8. 52, 55, 77, 1, 2, 8. 99, 96, 100. 99, 96, and we have what? 100. So these are the values that has been taken in the paintbrush. Okay, I am considering the same values here. Okay, no need to get any confusion. Okay, so I want to, my target element is integer target. Okay? I want to find what if the 8 is present inside this array. Okay, the moment you write this array, behind the scenes in your imagination, something must be running in your something should be running in your imagination. What is the something? Okay, mark the index numbers. 2 is being represented by the index 0. Okay, index always starts from 0. Okay, keep these things in the mind. Okay, now I'm running a for loop. Why for loop? Why for loop? Because linear search, okay, it always starts from the first value, which is also called as the 0th index, right? So I'm taking integer I equal to 0 because it should start from the 0th index. Linear search to start from the 0 and it should continue until it goes out of the boundary. Okay, what is the boundary condition? Okay, should continue from start from 0 and should end exactly at 100, right? So we cannot keep counting the indexes, guys. We cannot do that. Instead of doing that, what can I do? I can write a logic in such a way that I is lesser than a dot length. Right? This a dot length is nothing but the size of the array. Okay, since I am using the lesser than signature, it means the loop will terminate just before the size of the array. Right? So I plus plus. These are the things that we have learned in the for loop case. Okay, so for loop has been created. Okay, we cannot achieve our what we call it as, we cannot achieve our actual requirement only with this for loop. Okay, so this for loop is just like, it is just used for the traversing purpose. Okay, so when you do this, what actually happens behind the scenes? Okay, of course the cursor will be created, just keep running, that's it. Okay, so the for loop is just doing what? Okay, it is keep going to execute like this, but you need to do what? You need to do the checking. What checking? If the target value is present or not. What checking? If the given target value is present or not. What checking? If the given target, target, right? For that I am going to use what? The if condition. Are you getting this? Right? When the for loop is running, along with the for loop, you should specify a condition, if condition. If the target is present, in the first 0th index, if the target is present or not. No, first index, if the target is present or not. If the target is present or not. If is coming into the picture, so use the if loop, if condition. Are you getting this? Go back to the program and do if what is the name of the array? A. If A square within the square braces I will be changed from time to time. For the first iteration, I is going to be 0. Okay, so a of I means 22. Okay, it has extracted the value 22 in the first iteration, and that will be what? Compared with the target. Target is what? 8. Okay, in the first iteration, 22 is going to be compared with what? Target 8. condition is failing. Okay, it is false. Okay, this will not get executed. Okay, for the second iteration, 55 will be compared with the target. Fails. Third iteration fails. Fourth iteration fails. Fifth iteration 2 will be failed. Sixth iteration, of course, it is passing. Okay, the condition is going to be what? Satisfied. Then, if the condition is satisfied, what I have to do? I have to return the index number. System.out.println. Okay, what I am supposed to do? The target element is present at the index what? I. The latest value of I. Okay, at this point of time, okay, when 8 is double equal to 8, at this point of time, I is representing the 8. It means the value 8 is present at the index when given index. I mean, not 8. I'm sorry. I mean, okay, extracted value is 8. Okay, I is not going to be 8. I is going to be something. I mean, it is the count of the iteration. Okay, I is not going to be 8. Okay, let me run this. Okay, the target element is present at the index 5. 5 means I has been iterated to started from 0, right? 0, 1, 2, 3, 4, 5. Okay, when I equal to 5, okay, A of 5 is fetching this, retrieving the value 8, which is on top of 5th index, and the value is getting compared. Okay, and 5 is being returned to the console. Take pen and paper, and for each and every iteration, okay, write the value of I, and do it from your end. You will get these things. Okay, are you getting this? Okay, now the question is the second question. Second question is, if I change the target to 100? Okay, if I change the target to 100, it should return what? The index of the value 8. 100 is present inside the index 8. Yes or no? See, 100 is present inside the index 8. Previously 8 was present on top of the 5th index. Okay, what if I want to find the value 1? Target is, if I change the target to 1, I want to check if the 1 is present in the given array or not. Okay, let me change this to 1. Okay, 1 is the target element is present at the index 3. The target element is present at the index 3. Or we are getting the right answers, but the question is, what if I am giving something that is not present in the array? For example, my target element is 200. Is 200 present in our array? 200 is not there. Obviously, even though if the 200 is not there, definitely the linear search, okay, the cursor will try to identify if the 200 is present or not in each and every index. We know that it is not present, but the system does not know. It will start from the beginning, and it keeps going, and it will what? It will come out of the boundary, and when it is coming out of the boundary, it means the for loop is going to get terminated. Okay, when the for loop is going to get terminated, definitely the control has to come outside. Control has to come outside of the for loop. If any value is not identified, okay, so I'm trying to do here. I want to print the value, target value is not found. So we are sad that the target value is not found. You can do like this. Target value is not found. What if I am giving something like 2000? 2000 is there. It is not there, isn't it? Is it there? It's not there. Okay. The target value is not found. Instead of printing like this, you can print, you can just return -1. -1 is also, you can give a significance to the -1, like since the target value is not from that, that's why you're returning -1. Most of the cases, they will ask you to return -1. If it is present, you will return the index. If it is not present, you will return the -1. But there is a problem with our code. What is the problem? Okay, let us see that. I'm trying to replace the target value as 77. 77 is available, yes or no? Please tell me 77 is available in which index number? Can you please tell me? By looking at anyone with the eyes can answer this to me. 77 is present in which index? Second index. Do you agree with Chaitanya, everyone? Second index, right? So output should be what? Output should be 2. But there is a problem with this code. What is the problem? It is giving the right answer. At the same time, -1 is also getting printed. Okay. So I should print, okay, if it is present, I should print this, but I should avoid this. If it is not present, I should avoid this, I should print this. Okay, at any point of time, the value is present, I should what? I should execute only the if condition. If the value is not present, then the control should come out. Okay, but in our program, the program is written in such a way that if it is present, okay, we are getting the index number. At the same time, this is also getting executed. I should ensure that this is not getting executed. What can I do? I will just place a return statement. When I place return statement, okay, the moment the control hits the if condition, okay, the moment the control hits the if condition, it means definitely the value is present in the respective index, right? This will get executed, and the cursor will encounter this return statement. Okay, the moment it is encountering the return statement, the main thread will be destroyed here itself. It will not, what can I say, it will die. It will come directly out of the main method. It will not even bother about executing the remaining things. Okay, once you show the return keyword to the main method, it will skip all the instructions that is placed after the return keyword, and the control will directly jump away from the main method. So this instruction will be skipped. Now you see the output. The target element is present in the index 2. This is skipped. Okay, if I'm giving something like 770 is not available here, but I should get this, right? So we will get that -1. Okay, the value is present, if condition will execute it, and if condition is going to return, I mean, there is a return keyword, means we are destroying the main thread here itself. Okay, so the remaining statements will not get executed. The control will directly jump away from the main method, like a suicide. I'm not supposed to use the word suicide. It is a kind of thing. Okay, so you want to understand this better. You want me to explain this in the paint screen? Yes, no? Anyone? Are you getting this, or you want me to explain this to you about this return keyword? Come on. No, Sashpant, only Sashpant is getting this. You want me to proceed with the explanation, or shall I keep explaining this? This means, okay, I will explain this for you. Okay, let me create some space, guys. It's all about the control, nothing else. It's all about what? All about the control. Okay, so this is my code, right? My code is visible, isn't it, right? And I want to do what? Let me remove this. Okay, I'm keeping the instruction very simple. I want to find whether 55 is present or not. Okay, so for loop is there. Okay, when there is a for loop, it means obviously there is an iteration. Okay, so it will start from the 0th index. Okay, the target number is 55. Okay, so since if condition will not get executed because it is not matching with the target value. 33 is not equal to 55, right? So if condition will be skipped. Now 55 is equal to target, means this if condition, if this if block will get activated. Don't you think so? Activated. So after activation, okay, so if this is the main thread, okay, this statement gets executed, right? The output is going to be the index number 1 will be displayed on the console. The target element is present at the index 1. Okay, what is the next instruction? Return. Okay, so the moment the main thread is encountering this return, it means no matter how many instructions are there next to the return keyword, it will directly, okay, jump out of the main method. Okay, from here the control will be jumped away and this will be dead. Okay, that's why in the console are getting this. Okay, right, when you don't use return keyword, what will happen? Okay, the meaningless statement will be executed. Okay, this will get executed as well as this will also get executed. We want to skip this. So how I am skipping this? As soon as we find the value in the respective index, I am destroying the thread by using the which keyword? By using the return keyword, right? Okay, I hope this is making more sense, isn't it? Yes or no? People who are okay. Now next question. Okay, this is the linear search. Okay, linear search is what? It will search each and everyone. But one thing in the linear search, there is a big drawback in the linear search. If you ask me what is the big drawback, okay, the time complexity. So you don't have to worry about the time complexity for freshers. So they don't ask you much about this time complexity and space complexity. See, best case. There are best cases, not base case, best cases, and we have worst case. Okay, look at the time that it is going to take. Okay, in the best case, for example, if you find an element, what is the best case? Best case is, for example, the target element is 22. What is the best case? Okay, you are able to find this target 22 in the first attempt itself, when the cursor is pointing towards the first index, first attempt. Okay, this for loop will run only once, right? Okay, this is the best case. What is the worst case? If you have a target like for example, if you have a target 300, okay, it will go through each and every index. Okay, after completing all the searches, it will say the 300 is not there. Okay, so in our example, the size of the array is very small. It is recognizable and it is completely visible, and we can also memorize the values that is present in this inside this array. Let us take that if the size of the array is 1 lakh. Okay, size of the array is 1 lakh. So you want to find an element that is not present in this size. Okay, you want to find an element that is not present in this size. Definitely the cursor has to iterate through each and every element, and it has to check 1 lakh times, right? It keeps checking for 1 lakh times. Worst case. Best case, you can identify the element in the first attempt itself, but the worst case is what? You have to check 1 lakh times. Don't you think so? N times. Okay, it depends upon the size of the array. If the size of the array is n, iteration has to happen for n times, right? This n can be a very big number, 1 crore also. Okay, if you have the size of the array as 1 crore, if you want to find a value that is not present in this size, even in this size, what does it mean? This cursor, this iteration has to happen for 1 crore times, then you will come to a conclusion that the given value is not at all present. Don't you think that this is a kind of drawback that we have with the linear search? Are you getting what I'm trying to say? At least, are you getting what I'm trying to say? Time complexity. I mean, you can think like the amount of time that is going to take. Okay, in the best case, okay, in the first attempt itself it is going to find, but in the worst case, it has to take what? It has to take how many iterations? N iterations. It depends upon the size of the array. Since our size of the array is very small, okay, the the disadvantages is completely negligible in this case. But sometimes you will encounter a situation where the size of the array is going to be 1 lakh, sometimes 1 crore, sometimes 10 crore. Okay, and this cursor has to iterate each and every element inside this array just to tell that, okay, the value is not present. So this is a drawback. Okay, to overcome this drawback, actually the reason why I'm telling all this is you must understand why we need to follow different approaches. That's my intention. Okay, so time complexity, best case, worst case. Okay, so what can I say is, to overcome the drawbacks of the linear search, okay, we use or we go for what? Binary search. Okay. So in order to proceed with the binary search, please be informed that the array should be the what array? Sorted array. Means for the linear search, the array can be sorted or unsorted, no issues. The array can be sorted. Sorted means ascending order, or unsorted. There is no issue. But to do the binary search, what is binary search? I will explain you. But to do the binary search, the array must be in the sorted. The array must be the sorted array. Okay, let me take a small example. First, I will give you the insight. Then we will proceed with the problem. Okay, file new. Okay, I want to take an array, guys. I want to take an array like let me take it as 1. We will start it with 1. Okay, and 3, 5, 6, 7, 6, 7, 8, 11, 12, 14. A small array. Just imagine that this is an array. Okay, the array is in sorted order. Yes or no? Do you agree with me? The array is sorted, right? Ascending order, right? Okay, we are going to do what? We are going to do the binary search. Okay, we are going to do the binary search. So, for example, if the target element is, okay, before proceeding in the binary search, always remember that please mark the indexes. Okay, so that is the good programming practice. Okay, let me mark the indexes like 0, 1, 2, we have 3, we have 4, we have 5, we have 6, we have 7, and we have 8. Okay, what is the size of the array? Come on, someone comment in the chat box. What is the size of this array? I want to ensure that people are following me. That's why I'm asking you. What is the size of this array? Come on. There is no need to count. 8 cannot be size, guys. Size will be 9. How come 8? How many elements do we have? How many elements do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Why 8? Oh my god, I lost this. Let me write this really quick. 1, 2, 3. Index starts from 0. Okay, don't get confused with the indexes. Size is the number of elements, countable elements. 7, 8. Size is 9, right? Anyone has given 9 as the answer? Chaitanya correct, and Krishna Prasad correct. Size is, are you getting this? Index starts from 0. It doesn't mean that you cannot assume the size as 8 because the index is ending with 8. Size is nice. Just count the number of elements. That is going to give you the size. As simple as that. Right? And now, next question. Okay. So, we are understanding the binary search. What we are actually going to do, let us imagine that my target element is, I want to find element like target is 8. Focus here. This is going to be a very tricky problem. Okay. And, I'm going to keep it very, very simple. Try to focus here. Right, my target element is select. So in the linear search, what we usually did just now, we have did what? We are going to start from the index 0, isn't it? Index 0, and we will search each and every index to whether find if the 8 is present or not. Okay, but binary search, we are not going to do that in the binary search. Okay, so this is the binary search. Binary. For the binary search, what I am trying to do is I am going to I'm going to take two cursors. This is one cursor. This is second cursor. Two pointers, I can say. Pointers for the reference. It is not like, the pointers. It is just a pointer for the references. Okay. Two pointers I am taking. The name of this pointer is yes. starting index. Okay, the name of the pointer is end. E means the ending index or ending pointer, ending index. Okay? A cursor is being placed at the starting index and another cursor is being placed at where? From the ending index. Two pointers are, I have taken 2 pointers. Okay, by using these 2 pointers I am going to find the middle of the array. I want to find the middle index of this array. How can I find the middle index? We have a formula, right? If I want to find the mid value, what I can do with our references, I can say with our references start s plus e divided by 2. S plus e. So this is a formula. Do you agree with me? S plus e divided by 2. Okay, what is the value of s? S is pointing towards the 0th index and e is pointing towards the 8th index, right? I can say that 0 plus 8 divided by 2 is going to give me what? 4, right? So the mid value is going to be 4. Mid value is going to be 4. You agree with this? Mid is 4. Okay, so the moment I found the mid value, I am appointing another cursor that is pointing towards the mid index, which is what? 4. I'm doing nothing, guys. I have an array. Firstly, okay, I have placed an array in the starting index. I placed the cursor inside this. Just placing the 0th index and an index that which is the pointer that is placing at the last index. Okay, by using this 2, I'm finding the mid value. So mid value has been found. Okay, this is the mid value. Right? What is the formula to find the mid value? Starting index plus ending index by 2. I have got 4. Okay, so I have generated an array or a pointer. I have generated a pointer that is pointing towards which index? 4th index. Okay, now my job will start now. Okay, what I will do, as soon as I find the mid element, I will try to do what? If the mid element equal to if the value inside the mid element, is equal to the target element. Okay, what is the value inside the mid element? The value inside the mid element is 7. What is the target element? Target element is 8. Right? If the case is opposite, what I will do, I will change the starting index. I will change the starting pointer. I will move the starting pointer next to 2m. Next to 2m. Okay, and the ending pointer will be same. Okay, and again I will find the mid value for this s and for this. Why I am doing this? Why I am doing all this? Okay, for example, if you know that, okay, the element is 7, the target element is what? 8. So we need to find the 8. Okay, don't you think that the value inside the mid element is 7? 7 is lesser than 8. 7 is what? Lesser than 8. It means, don't you think that ideally our set space is going to be this side on the right side itself? Simple mathematics. Because the mid value is 7, but your target is 8. Definitely, since the array is sorted, don't you think that the 8 is larger than 7, right? 8 is larger than 7. Obviously, the value has to be somewhere towards the right side, yes or no? For example, if my target value is, let us say that my target value is going to be what? Going to be 3. The target value is given as 3, right? And if your mid element is 7, okay, mid element is 7, okay, 7 is greater than 3. Okay, definitely the target value will be towards the left side of the mid element, right? The search area has been limited, right? Because the array is sorted. 7, obviously 3 is lesser than 7. Obviously the search space has to be limited to this area, yes or no? For example, it's all about the direction, guys. For example, let me take to understand this better. Okay, so let us say that you are waiting for a train in the platform, guys. This is you. Okay, you are waiting for the train in the platform. Okay, and you have the booking. Okay, and you have a ticket. So your ticket says your berth is in the S7 coach. Your berth is in the S7 coach, and you are waiting for the train in the platform. You are waiting for the train in the platform. There is a train. Okay, I have a train here. Okay, so this is the train. So this is not a train. Okay, just imagine that the train is arriving. Okay, imagine that the train is arriving. It has to stop somewhere. Okay, it will stop here. Okay, so what is your ticket is S7, right? You are holding a ticket and your berth is in the S7 coach, but the compartment that you are facing is what? S3. Okay, where you will search? Okay, ticket is S7. Okay, and definitely you will go to the right direction and search for the compartment, right? Or you will go to the left direction to search for the compartment, right? Only right. Okay. For example, let us say that you are holding a ticket. Okay, that says what? Let me delete this. Okay. You're holding a ticket and it says your berth is confirmed in the S1 compartment. Okay, and train has just stopped where? Okay, your train has just stopped in this way, and you are facing the S4 compartment. Okay, where you are supposed to go? S4 compartment, and you should what? Go towards the left direction, right? Because S1 is what? Lesser than S4, which means your search space is what? Limited to the left direction. Okay? If your confirmed ticket is in S7, your search page is limited to the right direction. Yes or no? Which is deciding that? Okay, this is deciding that. The compartment that you are facing is going to decide which direction you need to go. Okay, if you are holding the ticket, what? If you are holding the ticket S6, let us say S6. Okay, you are facing S4. It means your search space has to be what? You need to move to the left, right direction. Yes, you have found the space, right direction. Okay, and if you are holding a ticket, a confirmed ticket, that is for S1 compartment. Okay, and which is going to decide which direction you have to move. The compartment that you are facing S4 compartment. So definitely S1 is lesser than S4. You need to move towards the left direction, right? The same thing is happening here. Let me remove this. Same thing is happening here. What? Your search, you got the middle value. Just imagine that middle value is nothing but what? You are facing the train compartment. Okay, that says coach number 7. Okay, what is your target value? Target number is 8. The target number is 8. According to Java, what you have to do? Okay, you need to reduce the search space. Okay, now your search space is limited to this area. Search space is limited to this area. You will do what? You will change the starting index here, and ending index is going to be is found to be the same. Okay, and again you will find the mid value. What is the formula to find the mid value? We have just discussed it, right? Starting index plus ending index divided by 2. Okay, what is the starting index? Starting index, S is pointing to 5. 5 plus what is the ending index? Ending index is pointing towards 8. 8. 5 plus 8 is going to give what? 13, right? Divided by 2. 13 by 2 is going to give what? 6.5, but in Java, the decimal, the floating point values will be ignored. So 6. So 6 is the mid value. Okay. Now this mid cursor will be pointing towards the index 6. Okay. Now this mid value will decide. Okay. Mid value is facing the value 11, but the target is set. Is it equal or not equal? 11 is greater than what? 8. 11 is greater than 8, right? So target value is 8, but you are pointing towards the 11. The mid value, the mid cursor is pointing towards the value 11, which is what? Which is greater than 8. So now the search place has been limited to what? This area. Only these two. Okay, this direction. Okay, now you will do what? You will decrease the end index. End index will be moved to m-1. Okay, end index and start index will be pointing to the same. Now you will find the mid value. Mid value is going to be what? Starting index plus ending index. Okay, starting and ending index are pointing towards the number 5. Right? 5 plus 5, 10. 10 divided by 2 is going to be given 5. Okay, now we got the mid index. Mid index is also going to point towards the 5. All the three cursors are pointing towards the same value which we said. Okay, now the checking is what? If the value that is pointed by the mid index is equal to the target. Yes, it is. Okay, mid double equal to 8. Okay, what is the index of mid? 8 double equal to 8. Okay, if this condition is satisfied, then the value is. Okay, let me write this in programmatically. You will get this. See, how many is, I know it is reducing the number of searches. Okay, you can say that, sir, I can use linear search. It is very easy. The code is also easy. Okay, but when you use linear search, okay, the number of iterations are going to get increased. But when you use binary search, it means it's just like this, guys. Okay, let me elaborate this in another way. We have time, huh? And it's not working. Okay, let us say that you have this is the what we call it as, this is the array you want to search for a particular number. What you will do, you will cut the array in 2 halves. You will cut the array in 2 halves. This is first half and this is second half. Okay, so depending upon the mid value, depending upon the target value. Okay, so if the target value is lying here, okay, then you reduce this search space to here itself, right? Search space has been reduced to here itself. Okay, and you will divide this array again into 2 halves. Okay, depending upon the mid value, you will reduce the search space. I mean, search space will be either reduced to this side or this side. Okay, the number of comparisons are going to get decreased. Okay, so mathematically I will show you what is really happening behind the scenes. Okay, then theoretically I will write a program on this. Okay, so stay focused here. Trust me, you need to repeat this once again. This video needs to be repeated once again. For example, okay, so let us say that this is my array. Okay, so in the beginning, what I am doing, okay, so we are reducing. Binary search means reducing the search space by how many times? So number of iterations is going to be what? N by 2. Okay, so again this is going to be what? Again you want to search. Okay, if the element is lying in the right side or left side, you don't know, depending upon the mid value. We'll take the mid value. Okay, and if you are trying to if you got to know that the element is supposed to be lie in the left hand side, okay, this is how the search space. So the search space is limited to the left hand side. So again this is going to be what? N by 2 by 2. Right? Simple mathematics. So n by 4. Okay, in the third iteration, okay, so take this. Okay, and the search space is limited to, and again this will cut into 2 halves to find the mid value. Depending upon the value and the target value, okay, you will limit the search space. This is the search area. So this n by 4 will again divided by 2. Gets divided into 2 halves. So this is n by 8. Simple mathematics. Okay, at last, after doing all these things, at one point of time, there will be only one index. Right? That is going to be what? There is going to be only one index. So this is 1. Right? And again go back here. So now you do what? This is the 0th level, and this is going to be what? This is going to be first level has been divided into 2 halves. Okay, and again what? Again do we have what? The second level, and again it got divided into 2 halves. Right? And again there will be one level where you will be finding only one array, only one index. Okay, let us take this as the kth level. Okay, so I can also rewrite this like, okay, instead of n equal to n by 2, I can write it like n equal to 2 to the power of, for the 0th level I can say that 2 to the power of 0. Right? For the first level, so this is before dependent. For the first level, let me write it here. not getting any space. Okay, for the 0th level I can say that n equal to n by 2 to the power of 0. For the first level, when the array is getting divided into two halves, I can say that n equal 2 to the power of 1. This 1 and the 0 are representing the levels. Okay, for the second level, n divided by 2 by 2. Okay, this is going to give n by 4, which is also called as 2 is to the power of 2. Okay, and for the third level, 8, n by 2 is to the power of 3. Right, and for the last, it is going to have only one index it is going to have. So it is going to be what? N divided by 2 to the power of k. So this is the formula that we have got. What is the formula? N by 2 to the power of k equal to 1. Okay, this can also be written as n equal to 2 to the power of k. Right, since I want to know the value of k, how many iterations that I want to know, I want to know the value of k. What I can do, I can apply log on the both sides. Log of n equal to log of 2 to the power of k. Mathematics, simple mathematics. Okay, after applying logs, this is going to become what? Log n. Okay, the power is going to come here, k log of 2. Right, I want to know the value of k, so k equal to log of n by log of 2. Right, so this can also be written as what? K equal to log of 2 n. So the question is, what is k? So this k is talking about what? Number of iterations. Number of iterations that one will see the binary search. Okay, if you have an array size of 10 lakhs, in the linear search, it is going to take, for the worst case, you need to perform 10 lakh iteration in the linear search. But in the binary search, okay, we will find how many iterations you will get. Okay, let me use the formula, I mean log calculator. Not this calculator, guys. I want to open the Google. Okay, give me some time. If you get logged out of the meeting, try to rejoin. Very important concept, this one. Okay, if I have an array, log base to calculator, log base to calculator, log base to calculator, we have. I want to find the value of 10 lakhs. Ones, tens, hundreds, thousands, 10,000, lakhs, 10 lakhs. See, so the value of k is what? 19.93. I can take it as 20. Okay, so when I do the binary search, okay, the relationship that I have just defined, okay, within 20 iterations we are going to get the value. Within 20 iterations for binary search. When I use the binary search algorithm, okay, binary search is going to give us the value, give us the results in 20 searches, in 20 iterations for an array that is with 10 lakhs in size. Because every time it is getting divided into off, and the search space is getting divided into off. Okay, if I do the same thing with the linear search, okay, I have to iterate for 10 lakhs times for the worst case. 10 lakhs linear. Okay, how many iterations I need to go through? 10 lakh iterations. For the array with the size of 10 lakhs. Or getting the advantage of this slide, right? So every time the space is getting divided into off, right? And so both are going to give us the same thing. Okay, even the linear search and even the binary search, we are going to get the output. We can extract the output, we can find that the value is there or not. Okay, but the advantages of binary search is that the number of iterations are going to get reduced. If you are not getting understanding this, you can repeat this video once again. Okay, especially this part, especially this formula part, you will get this. Okay, let us do some coding on this. Okay, I want to take the array in the sorted order. So what is the takeaway here, and what are the things that you need to keep in the mind when you do the binary search? Is the array should be in the the sorted order. 8, 19, 22, 34, 55, 57, 99. This array is in sorted order, so this array is eligible for the binary search. Okay, this is my array. How can I write the code for this? Let me remove all this. So I have an array. So I am going to take an integer start equal to 0. The starting cursor should be having the index 0, pointing at the index 0. Same thing, right? The beginning I pointed the array here, right? So same thing I am doing it here. I am taking another cursor, end equal to a dot length. A dot length is the number of values minus 1. Because index will end 1 less than the number of values, right? Agree? Right? This is the end. This index, end index, right? So I will run a while loop. Okay, this while loop start is lesser than or equal to end. Okay, inside this while loop I'm running a while loop. Okay, and inside this I will find the mid value. Integer mid equal to start plus end divided by 2. So 3 cursors are created. First cursor starting at the index 0, second cursor at the last index, and I am finding the mid value. Okay, and if a of mid, okay, we need to take the target, isn't it? Integer target equal to 55. Okay. If a of mid is equal to target, system dot out dot println the target is present at the index. Which index? Mid. Okay. Else if a of mid is greater than target. If mid value is greater than target, the search space has to be in the which side? The search space has to be in the right side, right? So end equal to mid minus 1. Else start equal to mid plus 1. Thank you for rejoining. My screen is visible, right? I am audible, right? Am I? Yes. Good. Just bear with me for 10 more minutes, okay? I will complete it as soon as possible. You may get this in the interview question. If you are getting this, then you will be the luckiest person. Okay. Let us test our code. Are we getting? The target is present at index 8. I will tell you what is happening behind the scenes. Okay, let me find the target 99. Okay, now you tell me the index of 99. I will compare with your answer. Now you tell me 99 is present in which index? Okay, let me post this to you. 10th index, right? Good, Chaitanya. Let me run this code. Are we getting the same value or not? Okay, 10th index. Now you tell me 19 is present in the which index? 19. Target value is 19. 19 is present in which index? Come on, everyone. 19, the value 19 is present in fifth index. Good. Let's test that. Fifth index, we are getting the right answer. Okay. Now you tell me the target 2 is present in which index? First index. Are we getting the same value? First index. Our testing is going good. Okay. Okay. Now you tell me the target 1 is present in which index? Zeroth index. Are we getting the same code? You must be wondering how we are getting this. Okay, these are the while and while. Okay, now you tell me the target 1 1 is present in which index? Is there anything like 1 1 1 1? Is there anything like that with in the array? Is there any value like 1 1 1 1 in the array? No value. So if that is the case, we should get what? We should get something like -1. But let me run this code. Okay, output is empty. So what I am trying to take? Okay, once this while loop is getting failed, okay, at last I'm using what? Given value is not present. I can do like this, or else I can directly do what? We are happy. We should be sad. Okay, since the value is not there. See, -1. Value is not present. -1. Okay, so you might be wondering what I have just done with this code. Very simple. Same thing that I have shown you in the paint screen, in the paintbrush. Okay. This is the binary search. Let me trace this for you in a quick time. Okay. Okay, now the program is completely observable. Okay, see guys, I have declared an array. This is, we have no doubts with this. I have specified the target value. For the time being, let us say that the target value is 55. Okay, so target value is also specified. Okay, I am, see here, you should start focusing from here. Okay, I am taking a variable start and I am assigning the value 0, and I am taking a variable end and I am assigning value 0. Focus on these two things. Okay, what does it really mean? What does it really mean? Forget about all this code. Okay, so we have an array. Okay, let's imagine that there are some values inside this array, and let us take for the time here, let us say except small boxes. Okay, forget about the values. Okay, now what you have to focus really on is these two. Okay, I have declared two variables. Okay, one variable is starting from 0, second variable is starting from the end. Okay, what does it really mean is, it is like I am appointing two cursors. This first cursor and this is last cursor. Okay, the name of the cursor is what? Start. The name of the cursor is what? End. Right? And then later what I have done after this, okay, I have started a while loop. Look at the condition inside the while loop. This while loop will run as long as the start is lesser than or equal to end. What does it really mean? Okay, this while loop will run, while loop is activated, while loop will remain active as long as the value of start is always lesser than or it could be equal to end. Okay, so let us say that this is traveling towards the right direction, and this is traveling towards the left direction. It will run. The while loop will remain active. Even here also the while loop will remain active. Okay, and even if both are overlapping also, while loop will remain active. Okay, the moment this end is crossing this, okay, the moment if they both cross each other, the while loop will get deactivated. While loop, it gets deactivated the moment the start variable becomes greater than end variable. Okay, if the while loop is getting deactivated, obviously what will happen, guys? The control will come outside the while loop, then this will be executed. Yes or no? The control will come out of the while loop, then this statement will get executed. You should understand one thing, okay? Whenever the while loop is getting deactivated, okay, it means the value is not present. When the while loop will get deactivated, when these cursors are not overlapping, then these cursors are crossing each other. Okay, start should always be in the left hand side, and end should always be the right hand side. Okay, when this logic is getting violated, okay, when the start is in the right hand side and the end remains to the left hand side to the start, it means the while loop will become deactivated. So that is how the while loop is coded. Okay, look at this particular the statement start should always be lesser than or equal to end. Okay, if this is violated, while loop gets deactivated. When this is deactivated, obviously the value is not present, then this is going to get executed. So far good. Okay, inside this, what we are doing, we are look at this variable. Look at this variable. Okay, inside the while loop, so this is the important thing that we need to observe. Okay, so we are creating another cursor which is called as mid. Okay, let me keep it to the same places. It was here, it was here. Okay, and there will be another cursor that will be what? Mid. Just like a train. Okay, you are standing in the platform. Okay, this is the train. Okay, and how you will move the direction depends upon the target value. If the target value is the target value is placed towards the right side of the mid, then the search space is what? This will be the search space. Okay, the target value is placed towards left side of the mid, then the search space is going to be what? The search space is going to be this. Who is deciding that? This mid value is going to decide that. Okay, the value that is pointing by this mid cursor will decide where the target is actually, because the array is sorted array. Just like a train, imagine the train analogy. Okay, and there are a couple of codes inside this while loop. What are they? Okay, I'm doing the same thing. If you find the midway is equal to target, then return the target element and paste the target element or print the target element, index of the target element, and return and break the loop. Or else change the change the end value, or else change the start value. If the target value is lesser than mid, change the end value. If the target value is greater than mid, change the start value. Okay, look at this sequence: if condition, else if condition, else condition. Okay, at any point of time, only one condition will get executed. Okay, what is your homework? Very simple. Take pen and paper. Okay, write the index numbers. Okay, write the variable for target, write the start index, write the end index. Okay, and run the for loop with the pen and paper. Okay, go through each and every step, observe the changes and observe the execution. You will get this. Okay, my diagrammatical representation is just for the understanding. Okay, the takeaway is very simple. Linear search is the what? It is not the good way of performing the searches. Okay, searching an element, because the time complexity is very big. Okay, binary search, to overcome linear drawbacks in the linear search, we go for binary search because the number of iterations will be reduced. That is the takeaway. So this is more than enough for the core Java arrays. Learn this wholeheartedly, full-fledgedly. Okay, you can become expert, guys, on the search.